Welcome to The Explainer. Today, we're doing a deep dive into something that's literally reshaping our world right now. We're talking about the anatomy of AI engineering, and specifically, how we're taking all this crazy AI theory and turning it into tangible reality.
Now, I know AI engineering sounds like just another tech buzzword you'd hear at a keynote, but actually, scratch that, it's a very real, rigid technical discipline. See, AI research is all about imagining what's possible in a closed lab, right? But AI engineering, that's the heavy lifting. It's the design, development, and deployment of these systems so they actually work out in the wild. If you really want to understand how the future is being built, this concept is your absolute anchor. It's basically the difference between a smart idea on a whiteboard and a functioning product in your hands.
So, bringing these systems to life follows a pretty strict three-part life cycle. It always starts with design, architecting the blueprint for how the thing should actually function. Then comes development, where you're building and training the models. But here's the catch. The graveyard of AI startups is literally full of models that never made it past step 2. The true test here is deployment. That means taking these super complex systems and integrating them into live, unpredictable environments without, well, breaking them. Because without that final step, AI is really just an incredibly expensive experiment.
You might be wondering, why is this process so incredibly difficult? Well, traditional software runs on exact rules. If X, then Y. But artificial intelligence by its very nature is probabilistic. It can be completely chaotic. You absolutely cannot just wing it. To harness the power of a complex neural network, you have to enforce rigorous, traditional engineering methodologies. We're talking relentless testing, validating, and building strict guardrails to make sure the AI behaves safely every single time. It's kind of like bringing the cold, hard discipline of bridge building into the futuristic, Wild West of machine learning. And when engineers apply these strict rules, they're chasing 3 absolute non-negotiable objectives. First up is scalability. A customer service bot needs to handle 10 users, sure, but it also needs to handle 10 million users without crashing. Second is efficiency. I mean, it shouldn't require a nuclear power plant's worth of computing energy just to generate a single answer. And third, reliability. If we're trusting AI to, say, diagnose diseases or land airplanes, usually accurate just isn't going to cut it. It absolutely must be consistently flawless. To hit that level of flawless reliability, we're looking at the ultimate discipline merger. AI engineering essentially bridges this massive gap between complex data engineering and traditional software engineering. Think of it like this. Data is the high-octane fuel, and software is the engine. You can have rivers of perfectly clean, structured data, but without the software frameworks to process it, you're going absolutely nowhere. And obviously, a massive engine is totally useless without fuel. It's the seamless synthesis of both that makes functional artificial intelligence possible.
When that synthesis actually succeeds, the impact is huge across some incredibly critical domains. This isn't just happening quietly in some random server farm. It is physically altering our world right now. In healthcare, this translates to algorithms detecting tiny anomalies in MRI scans way faster and more accurately than a human ever could. Over in mobility, it's the split-second processing that keeps an autonomous car from swerving into a pedestrian. It's managing complex global trading and finance, and it's completely redefining industrial automation. These are active, highly scalable systems running our modern infrastructure. So we've seen how merging software and data creates these reliable systems everywhere, from Wall Street to auto manufacturing. The structural foundation is built, the rules are getting much stricter, and deployment is scaling exponentially. The perceived magic of AI is totally gone, and it's been entirely replaced by rigorous, predictable engineering. Which leaves us with one really critical question to think about. As this discipline continues to mature and scale up, what industry will it completely upend next? Thanks for tuning into this explainer, and keep questioning the architecture of the world around you.